Dr. Sastry, and he has been working with DNV GL for the certification for oil and gas, maritime, and manufacturing sector for additive manufacturing. He's leading the Additive Manufacturing Technology Center of Excellence in Singapore, and he's a well-known contributor for the technology and implementation within the sector itself. Dr. Sastry, do you want to introduce yourself?
Yeah, thank you for having me, and also I welcome all those who are participating and also in the panels. Yes, additive manufacturing is close to my heart, partly because I've been working with this for almost more than 20 years now. So I started this journey almost in 1999 around in Belgium as a scientist there. So we were working in the first batches of printers, technology development, etc. But later I moved to Canada and started developing cold spray technology for power sector. For example, this nuclear power sector, and also for defense applications. But later I moved almost 14 years ago to Norway, and as a material specialist, I have been overseeing all our approvals of manufacturers. Means we have more than 2,000 manufacturers around the world. So that is combining my both traditional, conventional manufacturing experience and also I have developed a lot of schemes for certification of parts, both in maritime and oil and gas. And these are very well deep into very high technically demanding projects around the world. So then for a few years we have been asked by a lot of suppliers around the world how AAM can be adopted in maritime and oil and gas. For last 5 years I've been intensely engaged, and 3 years ago I moved to Singapore, and with the help of Singapore government we had set up this.
So how do you see additive becoming for certification agency like DNV? How do you see that being a challenge for additive? Because what we have as a service bureau, what we have also realized, like every machine is unique, every material is unique, every batch is unique. How do you standardize things? How do you certify things? How do you control quality? How do you give that as an idea to a user?
Okay, thank you. I think so. This is a very interesting question. Actually, this uncertainty, as you have explained, there are so many variables. This additive manufacturing sometimes looks like an ocean itself, with so many varieties of things, and each one you dig, there are hundreds and thousands of parameters. And how can we certify? The certification is endorsement of the quality that defines or that endorses the consistency, repeatability, and confidence in the process. So it's quite a challenging task. So for example, if I bring an analogy, like how the three phases of a matter, like a solid, liquid, and gaseous stage. If solid is the most consolidated knowledge, and liquid is not very much, you don't understand too much. So for conventional manufacturing or conventional parts and products, you have a 70-20-10 kind of thing. So 70% of knowledge everybody knows, it's quite crystallized. You have standards, you have procedures, everything. 20% is always advancing, 10% is so this is exactly opposite. 10% of AM knowledge is only solidified as standards or procedures or whatever developed. So a large part, you can say 70% of the part of additive manufacturing is in that sense is the liquid or gaseous stage, meaning it is not crystallized knowledge. So what we are using is the reference knowledge from our conventional manufacturing, and we know that if you follow certain procedures and follow a certain disciplined way of quality control procedures, you would end up with certainly a consistent, reliable, and a product that you can have confidence. So we are using that reference, and we are trying to continuously filter out what is the best knowledge that you can today certify, and what you should do to solidify the knowledge. Like running R&D projects is one of the biggest thing we are doing. We are at any time more than 10 joint industry projects with maybe 60 to 70 companies around the world. That is feeding us. So that is the strength of our certification. The data we collect from that is feeding back. Yeah, I hope.
So how do you exchange notes with organization like ASTM or AMS, which are also doing on the aerospace side? There are certain agencies for the medical side who are doing. So do you exchange notes for additive manufacturing with these agencies, or is it like everybody is working in their own areas?
Yeah, so again, this is very interesting. Probably several years ago, maybe we were all developing our things on our own, but today we all see that we are all, standard bodies like us, which we are very specifically working for oil and gas, maritime, etc., or energy sectors, whereas ASTM is writing standards that would support the standards we would be developing. For example, if we say you have to do a tensile test at that should be tensile specimen should be 10 millimeters below the surface. This is where we identify as the weakest region. ASTM actually develops something how to do this test. So there is a complementary role. So that is why we are working. For example, if you ask me, I am on several ISO ASTM committees. And also, for example, I am also working with the Singapore National Standards Committee and Singapore Military Additive Manufacturing Standards Committee, because all these participations bring us, they enrich from our knowledge, and we get enriched from their knowledge. So there is a quite fluid, what you can say, we have a very good interaction with these agencies, and this is how we are calibrating.
Most important thing what DNV and Additive is doing is like trying to co-own the risk of certain certifications for certain components for certain organization as an end use. So how does that risk mitigation, that risk handling, DNV do it for their end customers?
Okay, so actually, yeah, risk mitigation is our DNA. So since 1864, 156 years, actually, DNV GL is always doing this risk mitigation by developing methods that actually filter. Like we work like a filter, So whatever like you take a dirty water and filter it. So this is how we do this. And this risk management is done in different ways. For example, one is by identifying and designating the parts certification requirements. So we have a lot of design rules. For example, for maritime, we have what we call as a prescriptive rules, where the design rules specifically tells, for example, in maritime you have 1,000,000 parts. So all these parts are classified, which part requires what level of certificate, and most of the certification levels are only three levels. So highly critical, and medium critical and low critical. So highly critical means when this one fails, what is the impact of the failure, and also the probability of failure. So using this risk matrix, we stabilized already the most of the end user components. So if we know the components usage and usage, we already know how deep we should go in implementing, looking at the finer details. So that is one methodology. Second one, for example, in oil and gas is much faster movement than technologically advanced than maritime, where more deeper waters are exchanged more harsh environments where they always come with new materials, new technologies. So we have a methodology called technology qualification. Technology qualification is a systematic way of making the finding out what is known and what is unknown, and how do we normalize this unknown to known. So sometimes the technology qualification can be run fast in 2-3 months. Sometimes we have seen like some of the drilling heads etc. takes 1 year or so. So yeah, so I can say that either by identifying the certification needs in forefront, or by doing the technology qualification. And as part of the technology qualification, we have a failure method analysis, for FMICA analysis, and we use that analysis and see that what kind of failure modes that would be possible, and what additive manufacturing is bringing new failure modes. So that is why we are integrating this into this technology qualification, and helping our customers to mitigate the risk. So always you never find, a lot of customers ask is, if DNV GL certifies, can you tell that this part will never fail? We say no, it is not in our hands entirely. So but we can say that we can bring the certainty. At least we can tell at a certainty that how and when it can fail, or if it fails in a controlled ways, so that there won't be serious safety issues or safety accidents, or there won't be serious operational losses.
Economic
That is
losses.
the meaning of certification and risk management. Yeah.